Welcome to the video lecture series. In this video lecture, we can see about Z transform. Z transform is used for converting the discrete time sequence signal from time domain to frequency domain. Usually, it may be a bilateral time signal. Bilateral means two-sided sequence. The general formula for two-sided uh, sequence is x of z is equal to n is equal to minus infinity to infinity. This indicates the two-side signal handling, both the positive and negative axis, x of n into z power minus n. This is the general formula for z transform. It can also handle the unilateral or one-sided z transform, where the n limit varies from 0 to infinity. X of n is equal to x of z is equal to n 0 to infinity x of n z power minus n. Another important parameter that should be known while discussing Z transform is ROC, which is nothing but region of convergence. It's set of all value of Z in complex plane. Z is always a complex plane. Z is equal to R e per j omega. It has real and imaginary part. It is lying in a complex plane. We all know that it is represented by the circular plane for which x of z is finite. So x of z value, if it is finite, then we call that particular region as region of convergence. So coming on to the finite sequence of and how z transform is used for finite sequence, we can see an example. So though this is the general formula where n minus infinity to plus infinity, coming on for an example of finite sequence, here the n value is from minus 1. This is n value is minus 1. This is reference. N is equal to 0. This is n is equal to 1. Here n is equal to 2. So this is the value of n. So this is finite, right? N from minus 1 to 2. So here the limit gets changed from minus 1 to 2. X of n is at power minus n. X of n value is 2 at n is equal to minus 1. So x of minus 1 is at inverse, x of 0 is at power 0, x of 1 is at power minus 1, x of 2 is at power minus 2. Just expanding the summation as per the z transform formula. At the value of x of minus 1, the value is 2. So 2 is substituted here. At x of 0, the value is 4. So it is substituted. 4 into z power 0, z power 0 is nothing but 1. What is x of 1? It is 3. X of 2 is 5. So we get the finite sequence Z transform like this. Here, can you predict at what values of Z the we'll get the finite value as output? Except 0 and infinity, we get a finite value. When z is equal to 0, 1 by z, it becomes infinite. Similarly, when z is equal to infinite, also infinite value. So, apart from these two values, all other values of z, we get some defined values, some finite value. So, ROC is the entire z plane except z is equal to 0 and infinity. We all know that ROC is the region where x of z is finite. So for a left sided sequence and right sided sequence, you have to analyze and predict what should be the ROC. That is given as a task to you. Coming on to the infinite sequence means we don't know the length. So before going into the infinite sequence, we should know the basic signal representation of two terms, u of n and u of minus n minus 1. U of n stepping forth, u of n is equal to 1 for n greater than or equal to 0. So you can see the signal representation from n is equal to 0. U of n has some u of n value as 1 for all the instant of time. U of minus n minus 1 means the value 1 starts from minus 1 and it goes up to minus infinity. This is again up to plus infinity. It goes. Plus infinity it goes. So this is what difference you have to understand for our representation of a discrete signal u of n. N greater than or equal to 0, it is 1 for u of n. For u of minus n minus 1, it is time shifted and it is by 1 minus 1. So from that only the value of 1 starts. So you just remember this. And some of the important geometric series formula to solve the infinite sequences, this is used in max from 0 to n minus 1. This is again finite sequence. 1 minus this formula we always know take from mathematical concepts. 1 minus a per n by 1 minus c. If n is 0 to infinity, this is infinite a per n 1 by 1 minus c. So keep this in mind. So let us discuss the Z transform for an infinite sequence. Now the question is we have to find the Z transform for the given signal. The given signal is x of n is equal to a power n u of n. So now what we need is x of z and its ROC. So we have the general formula with us. It is minus infinity to plus infinity x of n z power minus n. So since it is u of n, we all know that u of n, it has a value of 1 from n0 to infinity. So the limit gets changed from minus infinity to 0 to infinity because u of n is having values only at positive side. So now we are going to take the n common. So it will become a z inverse the whole power n. How did I write this? 1 by 1 minus a z inverse. It is based upon this geometrical formula. A power n 0 to infinity, it is 1 by 1 minus a. In the location of a, we have a z inverse now. So based on that geometric formula, we write as 1 by 1 minus a z inverse. Now in order to find the infinite case, when infinity will occur for this value x of z, when this becomes 1, we will get 1 minus 1. So 1 by 0, it will become infinity. So when a z inverse is less than, so in order to find the ROC, which is the x of z value to be finite, what we do is it should be greater than a. Z should be greater than a. Then only we will not cross the infinite region. So the region of RO's convergence is Z greater than a. If Z is equal to a by a will come. So what happens is you will get 1. So 1 minus 1 becomes 0. 1 by 0 will become infinity. So ROC is not it is not a convergence region there at where z is equal to a. So what we have to do is we have to take greater than a. So ROC is greater than a for a right-handed sequence. So in this diagram you can see ROC is represented greater than a. This is the circular representation, is the representation of an Z transform where real part and imaginary part, RS radius, all those things we have seen in the previous video. This is for a right-sided sequence. Now an example, instead of a, we have some constants like 1 by 2 the whole power n e of n, same type. Minus infinity to infinity, it will become 0 to infinity for u of n. So instead of a, 1 by 2 z inverse the whole power n, 1 by 1 minus. Now guess what will be the ROC value? It should be greater than 1 by 2. So ROC is greater than 1 by 2. This is for a right-sided sequence. Now going on u of minus n minus 1. So this minus infinity to plus infinity, it will become minus infinity. If we substitute it like this, instead of x of n, if we substitute minus a per n u of minus n minus 1, what happens? Can you predict? Now the limit will be from minus 1 to minus infinity. Minus 1 to minus infinity, because the nature of u of minus n minus 1 is like that. So on interchanging the limits, we'll get opposite sign. So n is equal to 1 to infinity, a power n. So while we are going for interchanging the limit, inside also n changes its sign. This you should be careful. This minus and this minus remains same. Here minus 1 to minus infinity limit, it comes from u of minus n minus 1, because we know that u of n value is having the magnitude 1 from minus 1 to infinity. So this we saw in the previous slide itself. So due to this, it goes on. It goes on. So due to this only, we have changed the limit as minus 1 to minus infinity. We all know that at minus, the higher value is minimum. So minus infinity is at the lower limit and minus 1 is at the higher limit. So when we want to make changes to a positive limit, what we do is internally also we have to change the sign. So this is mathematical concept. So 1 to infinity we are interchanging, and here plus n will become minus n and minus n will become plus n. So next is what we are going to do is, why this step? Can anyone predict? This step is to change n equal to 1 to n equal to 0. So what we have to do this conversion? If we split this, if we want to add 0 here, we have to subtract the value of 0, right? At n is equal to 0, a power minus 0, z power 0. So at z power 0, the value is 1, a power 0 also the value is 1. So when n is equal to 0, normally we will be getting the value as 1. So what we do is we subtract 1 and we change the limit from 0 to infinity. So this is the thing which you have to take care for a left-sided sequence. So and the remaining things are same. One, you can take it outside because it is a constant value. And again, when you multiply the minus which is outside internally, you will get like this. So on application of the geometric formula, you'll get 1 minus a by z. So which can be simplified to get z by z minus a. Here the ROC is lesser than a. This is the thing which is different for a left-sided sequence. ROC is z less than a. You can take this again for finding the ROC. When this will become infinite? Again when z is equal to a. So we have to avoid this. Otherwise, we can take like this. It should be lesser than 1 for a finite value. So if we take this and we do z lesser than 1 by a inverse. Otherwise, we can say as z lesser than a. So this is how we get the ROC for a left-sided sequence. Z by z minus a is the x of z value. Similarly, if the constant is 1 by 2 the whole per n, similarly we can apply the formula minus infinity to infinity, then it is minus 1 to minus infinity. Again the same procedure. So ROC is z less than 1 by 2. Can you understand the difference between the right-sided and left-sided sequence now? Thank you for your patient listening. Stay tuned.